Welcome to my video on the radiation dosimeter meter monitor. A while back I bought a dosimeter. I live in Asia, and after the Fukushima incident, a lot of people got radiation detectors. I got this one. It's very readily available in Asia. It's called the SD3085 personal dosimeter. Gives you a display in microsieverts per hour or microsieverts, so you can change. To be honest, we've had really very little effect from the Fukushima nuclear plants over here. But it's a very boring grey display, so I decided to build a monitor for it. The only thing is, you can use any kind of personal dosimeter or a Geiger counter or something like this. You have to do a modification to it, and there's the connector with the modification so that you can connect them up. That gives connections to the power source and the Geiger counter circuitry to give you your pulse. So basically that's the dosimeter, and here we have the main unit here that I built. It's very tightly packed. It's a very tightly packed dosimeter. All the circuitry inside is quite heavy as well. There's three switches here, one button switch and two toggles. The first button is just for a reset, master reset. Then there's an LCD on and off for the backlight, so that you can turn off the backlight and save power. And then you have the on and off button here. You have a master reset here. Now, I did tell you there's a master reset on the side there. That's because this comes in, there's two dosimeter monitors here. This works independent of this side. So resetting this LCD, or you're resetting the timer with the dosimeter on this side, and I'll get into that a little bit later. There's two switches, button switches here for the menu select and the enter button. Here we have three connectors: power and external battery, if you want to put an external battery source on there. We also have the data cable, which is here for the computer, and we have a connection here which is your input from the actual unit itself. So if I turn it on, you can see, okay, so you can see that this is at a right angle to the LCD. The reason for that is that when it fits inside the bag, you'll be able to see this top half. But when you don't want to see the display on the LCD, turn it off. It uses virtually no power, and just see this side. But if you want to take it out, you can just take it out and connect up the external power if needed. Just leave the LCD on. And right, so basically this side you can see this is the timer, this is the power LED, this is the timer LED. You see it counting there. And when it gets to the end, which is about to, it will evaluate the radiation that is picked up, which will be 0 as there's nothing plugged into it. There you go, 1. So that's the lowest setting for this one, and 0 on this one here. If we turn it off, I will connect it up to show you it working. Okay, we do have a power cable. Like I say, power cable goes in here, and then you can connect this up to an external source. Or you can build a little battery box that will fit straight on there and give you an external power. Okay, so it's all kind of based around this little get up and go bag. So if you need to take it out, it will sit quite comfortably inside the bag. So it's kind of designed this way that you can take this power cable lead this fits into the bottom. Okay. Okay, you push that into the bottom, and that then fits into there to give you the display. As you can see, it kind of just pokes out there. Okay, and then this is designed to sit inside here, like this. Okay, so let's just take it back out for a moment and connect it. Okay, we'll put this in and connect up this. What's the connection? Okay, wrong one. Okay, this is the one. Okay, so push that in there, turn it on, boring display, easy to read. For the money though, I think they should have put a backlight on it. I mean, it wouldn't have hurt them to put a backlight on this to make it a bit more visible. Then we connect up the input to our Geiger counter. Okay, so we're going to switch this on now. Okay, so now it's turned on. Let's see if we can get a better view. Okay, so let's see what we have here. Okay, so it's saying you can choose the LCD or you can choose the GCM. The GCM is the monitor, the LCD is to change settings, you know, brightness, things like this. So if we go for the LCD. Okay, so now it's asking, you want a backlight, high or low. So let's, so you see the number of the variable going up. I'm not sure if you do see that. Oops. Okay, so if you can see that, it's actually getting, should be getting brighter and brighter, up to 240, 250, something like that. So there's the, okay, so accept that now. Okay, so now it's asked us to go to the else. Okay, so now we need to go to the, okay, visual or audio. Audio, there is a, oh, I forgot to tell you about the audio jack out there, so that you can set it up with histogram software, so that this can turn into a spectral and a spectrum, like a radiation spectral analyzer. Okay, so what we're going to do is we're going to go for visual. Okay, so visual. Okay, so reading data. Okay, so now that will read data until it resets, and then it sends out the data to the computer. So that brings us to the next thing. Here's the data lead that I made for it. We're now going to connect up the data lead, into here. Okay, and here's the monitor. Nothing on there at the moment because it hasn't actually, okay, 20 counts. Okay, so that's all now connected. Okay, and you can see its first bit of data has come up on the screen. If you're reading that well. Okay, it says raw data, it gives you the binary number, then it gives you the decimal number, and then it gives you a number of millisieverts over a period of 15 seconds. Okay. Okay, so now you can see the next data is changed to 24 as it's accumulated. Okay, so now that gives you a readout of 24. And most people probably don't even know what these counts per minute microsieverts are. So basically, I did the calculation so that it gives you a low, medium, and high here. So what we're going to do is I'm going to push this button here. You'll notice that resets, and if I push the button on the side, the LCD resets. Yeah? Okay, so what we're going to do, and then you can see the reset welcome screens come up, which I didn't show you before. Okay, so now what we're going to do is we're going to choose the GCM, and we're going to go for audio. And now the audio is going to, it gives you a count of the particles that it's counting, and it puts out a pulse to the so you can connect up this to the sound card. And I will make another video on that. So basically what I'll do is I'll just quickly show you the whole thing inside the bag. So we disconnect this, put it inside, quickly just plug it back in, do a reset, turn off the LCD. There you go, Geiger counter, monitor, ready to, ready to go. So, there you go. So you can just wear this, clip it on. I put a plastic bag over it to weatherproof it. I need one on here as well, really. Various cables it comes with. I'll do another video on this, working with the software and the histogram software. The analysing software that's available for free from I forget where it was now. I will find out and put some links up. Okay, that's it. Hope it's been interesting and inspires you. Source code and schematics will be available. I will get them up as soon as I can. But as for the actual design on how to build it, I think, you know, if you're capable of building the circuit, you'll be able to work out how to make this part as well and do that yourself. So I'll leave that part for you. But the source code and the information that's going to be readily available will be on my website as soon as it's finished. Okay, thanks a lot for watching my video.